experience any technical issue, support team will assist you. So as we have only presenter is Mr. Gulbir Singh. So sir, I am making you presenter. So you can present your presentation.
Okay.
Sir, I have make you presenter. You can start your presentation now.
Sure. Give me a minute. Yes, my screen is visible.
Yes, sir, it is.
Okay, so good afternoon all. My name is Dr. Gulbir Singh, paper ID 34. Thank you to the international conference on passive computation technologies for giving me the opportunity to present my research work. Basically, it is a review work. So this is the table of content. So I want to confirm that the slides are moving properly.
What, sir?
Slides are moving or they are still
No, sir, it is not moving right now.
not moving. Yes, wait, wait.
That slide number.
Yes, sir, it is moving now.
Okay. So it is it. If you don't mind, it will be not in full screen. It will be okay for you because when I do it full screen, I think the slides
No
are not
problem, sir.
moving.
No problem.
Okay, okay. So this is the introduction of the table of content, which is followed by the introduction about the topic. Then what is generative AI? We will discuss about the challenges of Gen AI applications, future of Gen AI, and the followed by the conclusion. So when you talk about the Gen AI, it is the basically the AI which is used to in the purpose of content generation, operative analysis, and automation. Where the new industrial area right now, industries are now moving and giving the doing the innovation. So basically, Gen AI is a use the unsupervised learning models and the unlabeled data to perform their task. So it also known as the advanced machine learning models, which particularly uses DL and NN for generating the we can say runtime or live contents. Example are can be the GAN AI and the we can say GPTs and DLLE. So this is the problem statement, the purpose of study. So the problem study basically it is used to investigate the transformation potential of the Gen AI while finding its capabilities, limitation, and the role in the future, upcoming future. So this study also identifies some major issues in the current Gen AI. We can say Gen AI which is having with us, and we try to address those we can say issues and by giving our opinion regarding that. So now objectives of this AI. So this research aims to provide valuable insight for the researcher to explore promising areas in the field of Gen AI. Now classification of Gen AI, challenges in Gen AI. Basically, what challenges we are going to face when we basically use the Gen AI. First one is the availability and data quality, because the sources of data which Gen AI using is not disclosed by the models or the inventor of those models. So this become major issues while we use those Gen AI. We don't know which data set they are using and how they train those data sets and how actually they are doing the training and testing of those data. So we don't get any kind of sources from these models. So this would be a we can say a major conflict while using these Gen AIs. Now the fairness by and biasness. So this AI model also have risk regarding the embedding risk regarding the amplifying the social biasness, which is done when these models are basically trained. So we also have some basically issues like the potential resulting in the discrimination or unethical outcomes. Next one are the ethical issues. So these Gen AI also sometimes indulge in some ethical issue or some manipulate these Gen AI in the field of ethical issue, ethical area, unethical areas. So basically, misuse of these AI for harmful purposes, such as creating deepfake, fake news, or will increase these significant and important concern about this Gen AI. Followed by this, we have the interoperability, which many AI models, especially DL system, which function as the black boxes, as we know that we just feed the input and we just getting the output. We does not understand the how the actual functionality is going on. So this also become a major challenge how the things are going on, and they have become make hidden by the developer or the we can say the inventor of the model, or we can say these model faces these issues. Now ownership and copyright, the many time we have seen that, because as we try to generate some content from these AIs, and many times they will not give you the we can say the sources. If you use the data which is generated by these AI, many time users can indulge in some copyright and ownership issues, legal issues. So this is also a major concern. So now we'll talk about the applications of the Gen AI. You can, I think this diagram is quite visible to you, so we can understand this majorly divided into 5 categories. Like it can be used for text generation, code generation, and followed by we can say application prototype. We talk about especially code generation, data set generation. So these are, and is also one of the major part. Like if you have to generate some images, videos and audios. These are the many vast areas of using generative AI for the daily purpose or the research purpose. Next is the future of Gen AI. So as we seen this table which displays the future of Gen AI. So in it is from starting early 2020. So we have only limited we can say future of this Gen AI, which basically for the spam detection, and we can say the autocomplete like autocomplete text like suggestions we are having. When you talk about current date, when you talk about 2024, so we can find out the final draft better than the human average knowledge. They can draft the content as the human is drafting. They are quite better in the performance, then text to product, then the final draft, then the we can say second draft means the next level drafting of the we can say generatable content. Now we talk about what will happen in 2013. So they become more professional as they become more of we can say influent as the professional writers. They can generate better content, better code. Right now they are doing, but the process is we can say learning process. They are learning in these fields. We can say better than the professional. They can design more better than the professional artists, professional designers. So they can create photographs as better than the professional photographer in the field of AI and robotics. They are doing many vast things. Next is the future and conclusion. So we have in the we have discussed the few surrounding of the this generative AI, which include the activities that need active monitoring of the AI generated content, uncertainties about the copyright protection. And despite of these challenges, right now businesses are increasingly adopting these AI solutions in their daily to improve their operation, while developer can explore more economic opportunities like offering customized generative packages, extensive testing to identify sustainable use cases. So now let's add one more thing in this. So how to address the challenges of these AI? So we have discussed a few challenges in the previous slide. So I want to add few points here, that if you want to enhance, we want to address those challenges. So we need to enhance the process of data collection and accuracy. And then next is the mitigating biasness through the careful data selection, and then improving the we can say improving more interpretability models so that biasness can be reduced, enhance or improve security and privacy by implementing robust encryption in these models, and also we also developing
Sir,
clear ethical guidelines.
sir,
Yes, sir.
sorry to interrupt you, but can you tell me which slide you are?
I am slide number conclusion and future scope. I am on
Sir, actually we are free zone applications.
applications.
Yes, sir.
Okay,
Now
okay,
it is
okay,
visible.
okay. So I think when in the full screen it is not moving. Okay. So I am talking about the addressing challenges. So these things we can implement to address the challenges of this AI. Thank you for all for listening my presentation very carefully. These are the references, few references I picked to for drafting this article for this renowned conference. Thank you very much.
Okay, thank you, sir. Any questions from our session chair?
No questions. We can proceed with the next participant.
Okay, ma'am. So who is next? Number 17. We have anyone from number 17 paper ID? Okay. Uh, Dr. Sandeep Kumar, can you tell me your paper ID? Okay, I think there's a network issue. Uh, Paper ID number 245.
Yes, sir.
Yes,
I am
ma'am.
present.
I'm making you presenter, so you can start.
Sure, sir.
Okay, now, ma'am, you can start your presentation.
Yes, sir. I'm sharing my screen. Is this visible?
Yes, ma'am, it is.
A very good afternoon to all of you, respected participants and all others who are present there. A very good afternoon. I am feeling privileged to present my paper in International Conference on Pervasive Computational Technology 2025. My name is Dr. Kamal, and the title of my paper is Unique Image Identification and Monitoring Using Blockchain. Following are the contents of my presentation. So basically, blockchain is a decentralized and distributed digital technology that records transactions across multiple computers. The key features include decentralization, immutability, transparency, and security. So, blockchain has its applications in almost all the areas of life. The major ones being finance and banking, like we talk of cryptocurrencies, decentralized finance, supply chain, logistics. So, in our paper, we have reviewed the use of blockchain in securing digital images because they are at a very high risk currently. So the proposed solution uses blockchain, steganography, and hashing for securing image transactions. Now, basically, there are numerous issues which are related to unique identification of images, who actually owns the image, and like how to track the actual owner of those images. So, this research paper proposes a method for tracking ownership of data which is present online and the authentic historic records. And if any changes are made to those images to detect such changes. Blockchain technology is making rapid progress in this field to solve problems. There are few existing solutions, but there are few drawbacks. So, in our current paper, we have incorporated techniques like p-hash, cryptographic hashing, and other concepts. So, objective was to develop a blockchain-based model for image ownership verification by using SHA, hash, and T hash, and to evaluate the performance on the basis of metrics like speed, accuracy, and security. A vast, extensive literature survey was conducted, and the few important papers among these, which have been shown in this table, they used cryptographic techniques and combined images. It was, in a way, a safe and impenetrable solution, but it had few limitations, like challenges in ensuring user friendliness, consistent execution, computational overhead, hashing, pricing and scalability, cost was yet another issue. So these were some of the limitations which were in the existing literature. Now, the methodology consists of microservice architecture, modular design for scalability. Following is the flowchart of the proposed system, in which we have a user interface, the application component consisting of three major components, including hashing microservice, steganography, and blockchain component. So, blockchain component mainly deals with ledger maintenance and owner tracking. Rest of the two are used for hash generation and watermarking. The proposed framework works in the set of 6 steps. The image is selected for tasks using tasks which include ownership tracking, watermark detection, and user record management. The technology used is Hyperledge, and Python language is used for this. The backend will include user records, hashes, and metadata. Modules are designed to define the architecture, which was given in the previous figure. These include hashing, steganography, and application components. So, a lightweight blockchain system to develop to store these images which have been reviewed, and to create APIs for communication between the microservices. The results which were obtained from this included less time was taken by these hashing techniques, and watermark images could be easily detected. Transaction time was very less, and when we compared it with traditional methods, so time was 0.65 microseconds, which is lesser as compared to the traditional systems. Collision rate was also very less. Transaction time and storage efficiency was very good. So the conclusion is that it is a major issue, and things like deep fake complicate it further. So it is a need of the hour to develop a system which can check watermarking, and which can check the authenticity of the images. So this could be a proposed solution which could be used in future with more affirmations, with more refinement to come up with a better solution. So in future, we are looking to address issues like deepfake detection and other attacks, and different layer 2 solutions. And we are also planning to expand the applicability to other digital assets like videos and documents. Currently, it's for images only. Following with the references that we considered while making this paper, uh, that would be all. Thank you so much.
Okay, thank you, ma'am. Do we have any questions from the session chair?
Uh, we can proceed with the next this thing presenter.
Okay. Thank you, Dr. Kamalpreet Kaur.
Thank you, sir. Thank you so much.
So now paper ID number 494. Mr. Madhusai.
Yes, sir.
Okay, I'm making you presenter, so you can present your
Okay, sir.
PPT. Okay, sir. Now you can present.
So 1 minute, sir. Sir, now my PPT is okay, sir.
No, sir. Your PPT is not visible.
Hello, sir. Hello, sir. Sir, am I audible? No, sir. Now
No,
is it
sir.
visible, sir?
Sir, I think you should rejoin meeting. There's some network
Sir,
issue.
1 minute. Okay, sir. Now is it visible, sir?
Yes, sir. Yes, sir. It is visible.
Now is it visible, sir?
Yes, sir.
Sir, yes, sir. Good afternoon. I'm very glad to share my experience. I have done a deep learning for healthcare applications that we have changed as explainable AI for heart disease predictions using cardiovascular. Sir, here our main objective is nowadays each and everyone is facing with heart disease, but we can predict like you are having heart disease. What our aim is to predict that heart. We have to predict that heart diseases. Nowadays, all the machines were there. Just it will tell like you are having heart disease, but we don't know at where part we are lagging. For that one, we came ideas are that using SHAP algorithm, SHAP additive algorithm. In that, what we can predict is how much of we have taken one data set which are having some parameters like heartbeat, respiratory program, daily exercise, and then gender. We have taken based on and then 1 minute, sir. Random forest and XGBoost, sir. We have done first with the random forest, sir. In random forest, we got that accuracy. In machine learning algorithm, we can find only the whether heart disease is predicted or not. For that one, we again went to XGBoost, XG gradient boost. It is also one machine learning algorithm. By checking both the algorithms, we come to know that we have to check which one will be better in between the both algorithms. We have done an comparison table between XGBoost and then random forest. We have got some accuracy values. Here, random forest is lagging behind the XGBoost, sir. Why? Because the accuracy levels will be low when compared to XGBoost, sir. And then whatever the values we got for the XGBoost, we went through that SHAP algorithm, adding of SHAP algorithm. For shortly, I will say that SHAP algorithm is an algorithm. Now current is an explainable AI. We can find the each parameter that how much it has contributed. For example, if we have taken 9 parameters, we don't know which parameter is getting positive and then negative. For example, if you consider I am the person having 21 age, but I am having obesity, and then I am not doing perfect exercise. But in heart disease, it will show that directly you are having heart disease. If I'm having heart disease, it will show that you are having heart disease. It will don't show if you are not having. But in sharp algorithm, what we can find is how much each parameter is contributing for heart disease. For example, whether it's contributing whether it's contributing positive or negative. I'm not doing exercise, but not doing exercise, it will give some obesity, but it will uh, like I will explain. For example, if you take obesity, it will give negative feedback. Why? Because I am lagging in exercise. For example, if it is there, it will show positive response. It is not there, it will show negative response. The main identification of sharp algorithm is it will contribute. It will show the contribution of each parameter, like how it is having. For that one, we have taken waterfall technique to visualize that one. It will show the parameter. For example, I will show, sir. So this is the waterfall technique. We have taken some parameters like CA, chest pain, age, sleep, old peak. These are all some parameters which we have taken from the data set. It has shown that how many of these having negative parameters, how many is showing that positive parameters. Here in last slide, it's showing that we have taken 9 parameters. In that CA is showing negative feedback. Age is showing positive feedback.
Sir, actually, your voice is not clear.
Sir, because it will depend on chest pain is 0 because chest pain mainly we can't say that chest pain only it will show that heart disease. Based upon that one, it will be depend upon our daily exercises. It will be depend upon our daily routine. It will be depend upon our sugar levels. It will depend upon our BP levels. So based upon that one, the heart disease may be vary. Now what we have added from the previous one is previous one we already they have done based upon the machine learning, sir. Now we have some more added that explainable AI to that one. It will show the sharp algorithm, sir. Sir, my voice is
Actually, your voice is cracking. It's not audible at
not
all.
clear, sir.
It's not clear.
Hello, sir.
It's breaking in between sound.
Sir, now I am audible.
Now it's perfectly fine.
Hello, sir. Hello, sir.
Yes, yes, sir. You are
Continue,
audible now.
continue.
Sir, I am audible now.
Yes, sir.
Hello, sir.
Yes, sir. You are audible.
Now it is audible, ma'am.
Yes, sir.
Hello,
You are
ma'am.
audible, but your screen is not presenting anything. You stop screen sharing.
Ma'am, I am audible now, ma'am.
Sir, I think you should rejoin the meeting.
Hello, are you there? Madhusai, are you there? Hello.
Hello, ma'am. Yes, sir. Now I will share, sir. Now I will share, sir.
Can you do it fast now?
Sir, sir, can I rejoin again?
Yeah, you can do that and do it fast.
Sir, yeah,
Madhu Sai, can you please present your?
Now I am audible, ma'am.
Yeah, you are audible, and now share your presentation and present your topic.
Okay, ma'am. Now my PPT is okay, ma'am. No, ma'am.
Yes, sir. Your screen is visible.
Sir, now my screen is visible, sir.
Yes, sir. It is visible.
Okay, sir, the main contents are objective abstraction introduction literature survey we have done, sir. Our main objective is that nowadays each and everyone is having
Don't
some
start it
doubt
from
on.
the beginning. You have given your presentation. Continue from where you left.
Okay, ma'am.
Yeah.
Ma'am, this is a sharp-based waterfall technique, ma'am. Ma'am, I'm audible, ma'am. Ma'am, this is a sharp-based waterfall technique. In this, we can find the each and contribution of each and parameter which is having negative and positive feedbacks. For example, if we take in here, we are having 9 parameters. In that, which one is contributed negatively, which one is contributed positively. For example, if we have taken a normal person should have BP in 120 by 80, but if we are having more than that one in the waterfall visualization, it will show that you are having a negative. You are not you are not doing well in that contribution of BP. For example, if you are having high obesity, like normal people should have 300. If you are having more than the 300, it will show that negative. You have to reduce your cholesterol. You have to do workout. For example, if you are daily doing exercise, we have contributed what are the levels we have setted. It will show that positive. There will be no glitches and backlogs in your exercise. It will show, man. The main objective of waterfall technique, it will show the contribution of each parameter, man. Ma'am. These are the references I have collected, ma'am.
I just have one question. Where from have you collected which data set you have used?
And we have used harddisease.cv, ma'am. We have got it from Kaggle, and then we have developed an interface, ma'am, for random forest and
Uh,
exhibits. We have used data set, ma'am.
have you used any real-time data set from any persons, and then
Yes,
you have tested your model?
not real time data set. We have used directly interface, ma'am. Directly values if you have. We have tested we use another one. Directly it will launch our gender and
Okay.
then what are the age we are having. We are having a high BP or low BP.
Okay. Okay. Thank you. Thank you so much for your presentation. Thank you.
Okay.
We are having how much sugar levels. Like that, it will ask, ma'am. After giving the all inputs, we have to check whether we are having a heart disease or not, ma'am.
Okay, sir. Thank you,
Have you
sir.
got it, ma'am?
Yeah, perfectly fine.
Okay, Mr. Madhusai, thank you for your time and your presentation. Okay, so now we don't have any participant left. So we are ending this session. Anyone has to say something?
Okay, ma'am. Thank you, ma'am.
Okay, thank you all. Have a nice day.
Thank you for organizing this session, and it was a very nice way the way you organized the session.
Okay.